Okay, we're going to talk about precipitation reactions and then build in the next video, get into net ionic equations. So a precipitation reaction is taking two soluble compounds. I'm going to take two soluble compounds and I'm going to form an insoluble compound. So just to review, a soluble compound such as sodium carbonate. I take solid sodium carbonate, and I have some here. So I take some solid sodium carbonate, and I drop it in some water and give it a stir, and it completely separates, right? So now as soon as it's completely dissolved, it'll take a minute, it will separate into water. So the sodium ions separate out, the carbonated ions separate out. So the ionic bonds can be broken if it's a soluble ionic compound. The ionic bonds can be broken by water to form this. So I get these separate. The reason we're writing two is because I get these separate sodiums, right? So there were two sodium ions in here. They're now separated by the water and surrounded by water molecules, and the carbonate stays as carbonate, but is surrounded by molecules. So I get those three different, each compound will produce three different ions in solution. And then there are insoluble compounds. So some ionic compounds cannot be broken apart. The ionic bonds cannot be broken apart by water. So if I take some calcium carbonate, and I take some of this and drop it into water. And I don't care how much I stir this, it's never going to dissolve, right? It won't dissolve. There are ways to get carbonates to react, but this calcium carbonate will not dissolve in water. It's an insoluble compound. Now, in a precipitation reaction, we're going to take two solutions that contain soluble compounds, but within them, there are the ions that can form an insoluble compound. So let's look at one as an example. We're going to form some insoluble calcium carbonate with this reaction. I'm going to take my sodium carbonate solution that I just made. I'm going to combine it with a calcium chloride solution. And when I do that, so both very soluble compounds, when I combine them, I form that insoluble calcium chloride. Because within these, what does the sodium have? Na plus, CO3, 2 minus. This calcium chloride has a calcium ion and two chlorides. When I take them separately, of course, they're all soluble. As soon as I combine them in a beaker and mix them together, now all of these compounds are bouncing around. When the calcium and the carbonate combine, and they are going to stick together and form this solid calcium carbonate. As soon as they are in this random motion in here, they combine, they are going to attach, opposite charges attract, and then the water can't get them back apart. The sodium and the chloride will also collide, momentarily stick together, but the sodium chloride is very soluble, so it just comes back apart. So what I will get is this solid compound forming. Now, what about the sodium and the chloride? They are just going to stay in solution. And so that's what I get. So there is my reaction. Let's balance it. Two sodiums, two chlorides, double this. And so in there, I will get solid calcium carbonate and I will get, so what else is in the solution? The sodium and the chloride didn't vanish. This is my new compound. That's my solid that forms. The sodium is still there. And that's my sodium and chloride. Now, what I can do to kind of make this a little simpler, let's represent this. There's a lot going on here, right? So the reaction is between these two guys. They have nothing else. They're watching it. I could show more sodiums and chlorides, but they're just watching the action. They're what we call spectators. So let's kind of break that up, and we'll introduce net ionic equations and then take it further in the next video. So let's break these up. What do I actually have in solution? 2 sodium ions in solution and a carbonate ion in solution. I also have calcium ion in solution and 2 chlorides in solution. What am I forming? Solid calcium carbonate and now let's represent that, what it actually is. It's not sodium and chloride combined. It's the sodium ions are still by themselves in solution. The chloride ions are still by themselves in solution. Whoops, 2 of them. And so I'm going to go ahead and draw the 2, right? I made them disappear. Right, so those, they're still there in solution, completely unchanged. Just like in math, if you have something that is on different sides of the equation, unchanged, they cancel. So let's cancel it. 2Na plus in solution, 2Na plus in solution. There's no change to them, so they cancel out on each side. 2Cl minus in solution, 2Cl minus in solution. They cancel because they're completely unchanged. Why don't I cancel the carbonate? Because here's carbonate, here's carbonate. Here it's in solution. It's no longer in solution. It's changed its form. It's formed a new compound. So it actually was part of the reaction. What is my reaction? The carbonate ions, when I mixed it with a solution that contained calcium ions, they combined to form this insoluble compound, calcium carbonate. This is called the complete molecular equation, and we will use that sometimes. But for a lot of these aqueous reactions, a lot of times it's just so much simpler. Let's clean it up and let's show what we call the net ionic equation. Take out the spectators, take out those ions that were there, but they were just watching the action, and just show which ions were actually a part of the reaction, and take the spectators out. Net ionic equation can be much cleaner and very useful way to represent chemical reactions.